Hello Mechatronics students, Andrew Dowland here, and in this video we're going to be talking about PLCs and how a simple format for sequencing to make one event happen after another event has occurred, after another, a format, kind of a recipe if you will, without getting bogged down with all the details about specific inputs and outputs. This is just a video about that step by step by step. How do we create a general sequence of events using ladder logic? So let's get into a couple of the details here. So this is an example program, and for your reference in D2L we're going to have this printed version loaded up for you, and so you'll be able to reference this PDF file and build your own and go from there. But let's get in, so that'll be a reference for you as you're going through this lab. Now let's take a look at the Studio 5000 project that's been created. First of all, I've got a whole bunch of tags in here, and these tags are not assigned to any particular addresses. So let's take a look at the monitoring tags. Let's see, I set them up as a lot of locals. So these are, and I guess I got a mix of local and global in here, but that's all right. You can see I've got, they're basically all Boolean types. I got step 1 and step 1 conditions, step 2 and step 2 conditions, 3 and 3 conditions, step 4 and 4 conditions. I've got a start, I've got a stop, and I guess globally, I had put in another one that was called run and end, and again, they're all just Boolean types. So once I've created those Boolean types, let's get into the actual logic here, and I'll reference this. So the very first line of the program that we have here is a seal-in circuit, so it's otherwise known as a latch. So when the start bit is on, and evidently the stop bit, I can right click on these and toggle them. And the neat thing about the program that I have here is that I don't have to worry about any physical inputs or outputs. These are all just tags inside of the PLC memory, so I can run this in this mode here. Evidently I do need to download and run it in order for it to work, so I'm going to go ahead and download the program. And yep, I'm gonna have to be plugged into the web or into the PLC network, so that was my fault here. Probably have to cancel that, but hey, this is good stuff because that'll probably happen. It's nice when things get flubbed up in these videos so that you guys can see, oh yeah, that makes sense, I got to be plugged into the network and communicating with the PLC before this is going to have a chance of working. So back here, let's go to this Who Active, and we should be able to find our PLC now that we're plugged into the network, and I can now go ahead and download. So my PC was just not plugged into my PLC network. So we're downloading. This should just take a few moments. All right. So now we can see the events happening here. So in this case, I'm going to toggle that stop bit off and just go through this basic program. So you guys can see this seal-in circuit, this latch circuit, that's going to turn on the run bit. And then you can see I've recycled that run bit as permission for pretty much every step or every line in my program. So I have to be in run mode, and if I'm not in run mode, then it cancels the entire sequence. So this would be a great example where you have one push button to start an operation, and then another push button here will stop it. So I'm going to assume that the stop bit is a normally closed input, and so it should be generating that that on. Should be generating an on signal. Alright, so as you guys can see here, once I'm in run mode, and you know, pressing start just by like a momentary press would latch this circuit. Now I can let go of the start button, and now I'm in run mode, and run is permission for everything else. So the next part of this would be step number 1. Well, what kinds of things do we need to have happen before we can get into step number 1? And in this case, I just have it set up as step conditions. Well, let's talk about that for a little bit. So one example would be a number of sensors might need to be in a home position before you could start a sequence of operations, such as maybe this rotary arm that's over here. Perhaps it needs to be in this position before the PLC is permitted to start, or the first step is allowed to start. So there's a sensor back here. It's like, oh, that sensor has to be made before I can begin step number 1. So these are the permission kinds of things we're talking about. So back to our code here. Once step 1 conditions have been made, that sensor is home, maybe the pressure sensor, you know that you actually have compressed air pressure to your system, something's up to temperature, a motor's running, those kinds of things would need to be on before we can go to the first step. So I'm going to toggle the step 1 conditions. And then you're going to see step 1 is turned on. And if you go to run number 2, we're in run mode, check. Step 1 already happened, check. And now it's waiting for the second set of conditions. So perhaps this is a air cylinder that needs to extend and make a sensor, and that is what's going to give you permission to get to step number 2. So once step 2 has been made, then it is allowed to go on to the next step. So you're going to see a format that's very, very similar here in all of these conditions, right? Run the previous step, the what's required to get to step 2, and then step 2 is going to latch itself on. The next one is exactly the same. Run mode, step 2. What's necessary to get to step 3. Step 3 turns on and it latches itself on. Now the neat thing about this sequence is if I went here and toggled this bit on, so let's say, oh, we're ready for step 3. Step 3 cannot happen unless step 2 has already occurred. So it basically locks it in. Says these are the steps we need to follow. Boom, boom, boom. So now if I were to go ahead and launch this, step 2 conditions have been made. Step 2 turns on, it latches on, and it's going to stay on until the run bit stops. Basically, that's what's going to disable this whole thing. So if I went up here and disabled the run bit by, say, pressing the stop button, okay, now we're out of run mode, and because that was permission for everything else, it's going to stop every bit of action. Okay, so we'll go back here and get these things going again. We're back in run mode. Step 1 conditions have been made. And I guess I left these on. So let's go to step 3 conditions now. Toggle that. Step 3 is engaged. Okay, I'm going to scroll up a little bit so you can see the rest of this. Now this is an interesting piece here because the last step is step number 4, and once its conditions have been made, it will latch on and then take a look at rung number 5. Once step 4 has been made, we're going to energize the end bit, and that's going to stop the entire program. So the end bit is used way up top here and says, okay, there's 2 things that can kick us out of the run mode, and that would be pressing the stop button or ending the program. If that normally off bit there were to get energized, it will break the run. So let's see what happens here. And this is going to happen so fast we don't even see it. Boom, boom. It kicks us out. So the end bit is energized. And if we go back up to the top here, oh, I have my start bit energized, which is throwing some wonky things into the mix here because it's wanting to start, stop, start, stop, start, stop constantly. So anyway, the end bit got energized, and that breaks the run, and that's the end of the program. So that's a very basic program. We didn't worry about any inputs or outputs. We're just looking at the logic behind a sequence of events. Go from one step to the next step to the next step. So I want you guys to create this program using the supplied PDF file that shows these bits. They're all Boolean types. So that'd be your first part of the exercise, is creating all the tags. They can be local tags. Once the tags have been created, create this logic and then download it to the PLC. Experiment with it. So wrap your head around, what does it take to go from one sequence to the next sequence to the next. All right, when you're finished with that, demonstrate that you've got it done, and then we can move on to some next labs that would incorporate actual devices with sensors and real inputs and outputs. So until next time, have fun and good luck to you.